Wireless network or Wi-Fi have become very popular and can be found in most home networks, hotel, offices, and are even common now on commercial airlines. Most consumers and corporate communication devices such as laptops, tablets, and cell phones have built-in Wi-Fi. Wireless technologies uses radio frequency or RF in the place of a layer 1 wired network and is standardized by the IEEE 802.11 specification or 802.11. The goal of administrators who are tasked with design, installation or maintenance of a Wi-Fi network should be to ensure that it is just as secure as wired network. The devices that provide the interface between the Wi-Fi network and the wired network is known as a wireless access point or an access point or AP. Fundamentally, AP can be centrally managed, which is commonly called lightweight due to the initial use of the lightweight access point protocol or LWAPP. Even though LWAPP has been replaced by the control and provisioning of wireless access point protocol or CAPWAP, which is a newer, more secure protocol. We still use the term lightweight to refer to a centrally managed access point. The device that manages the access point in this case is known as the wireless LAN controller or WLC. The access point is involved with the real-time processing of sending and receiving 802.11 frames, beacons, and probe messages. 802.11 data encryption is also handled in real time on a per packet basis. The access point must interact with the wireless client in a low level which is known as the MAC layer due to the interactive nature of these processes. It is important that the function be kept as close to the client as possible and therefore reside on the access point. The management functions are not integral to handling frame over the RF channels and should be centrally administered. Therefore, those functions are moved to a centrally located wireless LAN controller and off the access point. The two devices must use a tunneling protocol to carry 802.11 related messages. And also client data, lightweight access point, and wireless LAN controller can be located on the same VLAN or IP subnet. However, they can also be located on different IP subnet in different locations. The CAPWAP tunneling protocol provide this service by encapsulating the data between the LWAP and the wireless LAN controller within the new IP package. The tunneling data can then be switched or routed across the campus network. In a lightweight managed AP configuration, the wireless LAN controller is tasked with performing functions such as dynamic channel assignment, transmit power optimization, self-healing wireless coverage, flexible client roaming, dynamic client load balancing, security management, and also the task of a wireless intrusion protection system. The other method in which access points are deployed is known as autonomous mode, whereby each access point is independent and not managed centrally. Autonomous APs are typically found in home network and other places where a centralized management doesn't make sense or isn't more effective. Autonomous APs are also a natural extension of a switch network, connecting wireless SSID to wired LANs at the access layer. Autonomous APs are self-contained, each offering one or more fully functional standalone basic services sets or BSS. A basic service set is a wireless service that is provided by an access point to its client. The AP services an aggregation point for every device that want to use the BSS unique BSS ID that is based on the access point's own radio MAC addresses advertised so that wireless devices can find it and try to join the wireless network. The BSS ID is a machine readable name tag that uniquely identifies the AP. In addition, the access point advertises the wireless network with an SSID, which is a string, text string con containing a logical name as a non-unique human-readable name tag that identify wireless service. It is common to see many SSIDs being advertised in a building that has multiple offices, each with its own wireless network.